Go through the lab code. So what we have today, we got the lab packet pulled up. You are all in possession of a copy of the lab packet. These are actually really nice labs. Like I might have told y'all yesterday. I am in search of this original lab book, so I can get even more assignments out of this book because it's really nice. One of the things I like about it is it's fully self-contained. If you take your time, obviously you don't have to read through all the objectives in the glossary, but I would encourage you to do more reading than you normally do. That being said, I also know that I'm teaching a dual credit class, and so out of all the kids in the school, y'all are the most likely to actually read something as opposed to just skimming it. But if you read through this lab packet, you really shouldn't need anything outside of the packet itself to answer. Besides maybe just a couple simple Google searches if you're not really familiar with something they're talking about. But in general, these packets walk you through every step of the way and tell you what to do. And so if you get to a question and you read the question and you're like, I don't know what it's asking, go back and read the paragraph before that, and there will probably be a pretty good explanation to kind of set you up. And so instead of just going straight to question one, you got question one right here. Read the little paragraph in front of it, and it's going to kind of set up question one and tell you what you need to do, and then you get started going through it. So my advice is, as you go through and answer every question, which this is going to be a paper thing. Yeah, this is going to be a paper thing. For some of these, maybe I'll set up like an answer document in Canvas where you can put the answers in. But this one, you have to do some drawing, and so it'll just be easier for everybody to just give me the paper copy. So make sure as you're answering stuff to cross off the question, and here's why. I don't know if it's this one. I think it is for this one. There's a couple questions that ask you to do something somewhere else, or maybe they don't have like an answer sheet here. So they give you a couple steps here. They got 5. I don't know if there's an example of this. But just make sure that you're doing every single question, because there are a lot of questions on here. There's a lot of reading. You go back and forth. And so I don't want you to miss a couple questions because you thought you already done them and you go on to something else. So take your time. Make sure you're doing all the questions, filling out all the answers, doing what they ask you to do. And I guess, so notice also, if it's omitted, I already have it omitted. It's got the big X on it. Don't worry about it. This would be questions that reference a figure that we don't have in the copy that I made. So there's no picture for you to look at, or it's just not that important. So there's X over it, omit it. And let's see. Everybody look at this picture real quick and see. Can you see, it looks like it's not too bad. Can you see the difference between layer A and layer B? It's not the best physical copy. Or barely. Know that there are 2 layers. There's a really thin, I'm turning the lights on. There's a really thin crust at the very top, and then you get into a layer like slightly below that. Where did I put this? Let me see if I can look at it. That's not too bad. You can see the A, you can see the B, and the S waves and P waves. All right, that's not too bad. You should be able to figure that. If you have any questions on that, let me know. And then real quick before I turn y'all loose on this, because I don't think this is going to be too bad. Let's do this example. So these last 2 pages, everybody turn to these last 2 pages. We got a map here, and we got an example just above that with 3 recorded earthquakes on seismometer and a little chart here. And I want everybody to kind of get how we do this. And so this is what I want to go over so we get a little experience doing this before the lab has us do it. So we have 3 stations. Notice they're in different parts of the country. So we got a Los Angeles, California station, we got a Houston, Texas station, and we got a St. Louis, Missouri station. They have each recorded the same earthquake. What we want to do is we want to get some data on this earthquake, and we want to come over here on this map, and we want to figure out where our earthquake happened. They already have our 3 locations plotted. We have Los Angeles, we have Houston, and and we have St. Louis. And so those are going to be our 3 seismometers where we have to triangulate our data from. So first thing we need to do is we need to get a time difference from the P wave and S wave arrivals on these 3 setups. And you can kind of see from yesterday, the P wave is going to be where you get your very first really tiny squiggles. The S wave is where your squiggles are going to pick up just a little bit. It's like the intermediate stage, not the biggest squiggles, but not the smallest ones. So I'm looking for the start of each of those. And actually, let me do this where I can kind of draw it for a second, and then I'll show you how to use the chart. The chart is probably one of the weirdest things. You'll see it's a really weird chart. Let's see, print screen, and let's go to Aspire. Active Inspire.
The little ones of P-Wave?
Yes. Let's see. Warning. Why do I have a warning? What? Warning. Okay. I'll trust you. Yeah. All right. So what we have here is we have our 3 stations, and what we want to get a time difference. So notice down in the bottom left corner, they tell you that every line, the gap in between every line is 1 minute. Does everybody see that? So every line on this chart is 1 minute. If I want to mark the P wave, let me get a marker going on here in red. So when I mark the P wave, I'm looking at right here for the start of that first P wave, right where that very little squiggle starts to begin. And then the start of my S wave will be the start of my next biggest squiggle, which will kind of be right there. And so the time difference that I'm seeing between those is if I start at this line, 1, 2, 3, 4, 5. Does everybody see that and agree with it? 5 minutes for Los Angeles. Is everybody good with that? See what I did? Yeah. So you want to do the same thing for Houston and St. Louis. Get the time difference of what you think it is between Houston and St. Louis. I'm looking at right here for my S wave or my P wave, and then right here for my S wave. And then, yeah, I think it's right there, Okay, what did y'all get for Houston and St. Louis?
Yeah, 2.5 for Houston.
About 2.5. Did everybody get 2.5 for Houston? And then you just got the 1 for St. Louis? Yeah. So pretty straightforward. We got 5, 2.5, and 1. And actually, let me go back. Actually, let me erase this. That's not an eraser. There we go. And let me put my numbers over here just a little bit nice and neat. So we have LA equals 5 minutes. Houston equals 2.5. And then St. Louis equals 1. And then we'll have a dash. So now we have our times here. Now is the weird part. We need to take these times and turn them into a distance. And the distance is going to be a weird part. So we got 5 minutes, 2.5 minutes, 1 minute. So what you want to do for this distance, if I pull this up properly, you're going to need like a ruler or a piece of paper. Like another piece of paper will be fine. Anything that's kind of straight to help you kind of visualize this. So what you have is a chart, and let me make sure not everybody's got a good chart. We have is a chart, and you have 2 lines on that chart. You have an S wave line, which is red, and it's the taller one, the one that's higher up. And then you have a P wave line. And then you have 2 axes. Your axis on the y-axis is minutes, which we've already measured, which are minutes between arrival of P wave and S wave. And then distance down here on the bottom in miles. Note that there's some, like I think maybe the one in your lab also will have a distance in kilometers up top. So make sure that you're answering in the right unit, because some of them they ask you in miles, some of them they ask you in kilometers. So you just look at the top instead of the bottom. But what we need to do here is actually really weird, and it takes a lot of people a long time to get. Still, it's difficult for me. You want to take a piece of paper or a ruler, and you want to lay it flat, and you want to kind of slide it up the chart until what you're looking for is a 5-minute time difference between your P wave and your S wave. It depends on your time. So we have 3 different times. We had 5, 2.5, and 1. So what I'm looking for is a point where I have a time difference of those times for this chart. And so watch when I find the 5, and then we'll do the 2.5 and do the 1. So if I come up here, actually, no, I'm doing this wrong. My bad. Instead of horizontally, you want to do it vertically. And so notice as I start at the left and move to the right, as I drag it this way, my lines start off really close together. And then the further to the right, the further to the right I go, the more my lines spread apart. Does everybody kind of see that? That's your time getting further and further away from each other on your P waves and your S waves. So what I want the point on the chart where I have 5 minutes difference between this P wave line and the S wave line. So let's just start, and we'll move over a little bit. If I stop right here at the 500 line, right here, I've got maybe like 1.5 minutes in between my P wave line and my S wave line. Does everybody see that? So 1.5 minutes is not good enough. I need to keep going. Go over to like the 1,000 line. The 1,000 line is like 1, 2, maybe 3 minutes. Still not good enough. I need to be up to 5 minutes. So let me go over to the 1,500 line. The 1,500 line is 1, 2, 3, 4 minutes still. So getting closer, but not quite there. If I go all the way over to the 2,000 line, start at the P wave line and go up 1, 2, 3, 4, 5. That's going to be pretty close. Does everybody see that? So if you go to the 2,000 miles down here, am I scratching my board? What is happening? Maybe it's covered with board marker. I see. Okay, I understand now. Go over to this 2,000 line. Come up until you see the P wave curve, which crosses at what? Like a little bit over 6 minutes, right? Maybe like 6 minutes and 15 seconds, something like that. Does everybody see that? So my P wave crosses this 2,000 line at right about 6 minutes and 15 seconds. And then if I go up to the S wave, it crosses that same line at roughly about 11 minutes and 15 seconds. A little bit over. Maybe I could go a little bit to the right of that 2,000 line. Maybe I call it 2,100. But that line right there is going to be a 5-minute time difference between my P wave and S wave. Does everybody kind of see that? Sorry. And so that is actually going to tell us something. And what it tells us is our distance from our epicenter of our earthquake to where we recorded it. And so actually, let me see. Can I go back to this? Can I move this up? Grab. Yeah. No, I cut it off. All right. Fine. It's back to where it was at. So for this 5-minute one, we did our measurement. And what we came up with is, let me put a line here. That'll work. Insert shapes on a line. Let me drag it right about 2,000 here. Oh, that's not a very good line. That'll be pretty close right there. Yeah, I'm going to guess 2,100. And let me make it bigger so everybody can see it. Shape outline. Wait. Let's make it a little bit bigger. Okay, so let me come back down. What we said is right about right here, right about 2,100. I've got a 5-minute difference in between that P wave and S wave line. And I can just count it up. 1, 2, 3, 4, 5 minutes. I'm about at the same point. Does everybody kind of see that? Now, that tells me if I trace it all the way straight down, that tells me I'm how many miles away I am from my earthquake. So 2,100 miles, 2,100 miles for the Los Angeles station. So come back over here. I have 2,100 miles. So now let's go ahead and plot this one. And we'll come back and do the other two in just a second. So what I do with this 2,100 miles, I go down to, well, I'm gonna have to get I'm gonna have to mess up my little thing for this. So let's go ahead and finish these. Sorry, I'm getting out of order now. I was gonna go ahead and do the map, but I'm gonna have to mess up my writing thing here. So let's go ahead and do these. What are the other two? I need 2.5 minutes. And I need 1 minute, right? So 2.5 minutes is obviously going to be further to the left because I want my lines to be closer together. So let me just grab this line and move it over this way. And we're looking for about 2.5 minutes. So if I stop it right here, about what, like 800, 900, that crosses right here at 3. The P wave crosses right here at 3. The S wave crosses right there at 6. So that's about 3 minutes. I need to get it down to 2.5. So I'm going to go a little bit lower. Let's see what we got. If I drag this over here, now we're talking, I'm at around 700. And this would be what? 1, 2, that's not quite 2.5. It's a little bit under. So let me go back. I'm thinking maybe 800. Is that right? So at 800, we're crossing with the P wave. I'd say a little bit under 3, maybe like 2 3/4. And then if I go up, I got 1, 2, and then maybe a half. That's tough. The halves are kind of tough. But I think I'm close right here at 800. Maybe I'm going to say 750. I think that could be good. It's going to be somewhere in between 700 and 800. So I'm thinking around 750 should probably get you close to 2.5 minutes. There's 1, there's 2. I think that's about it. I'm a little bit over 700. So let's go ahead and make our notes for that. So Houston is going to be about 700. We'll just call it 700. And then St. Louis is 1 minute away. It's going to be the closest. So if I come back over here, I need to go pretty close to get this all the way down to 1 minute. So come on, line. There we go. Well, that didn't work like I wanted it to. 1 minute's going to be right about there. So I've got the line right about 300. And you can see 300. I cross right about a little bit over 1, the P wave line, and then the S wave line crosses a little bit over 2. So that's about a 1 minute difference in between where those are crossing. So I'm going to say that's 300 miles. Come back over here. 300 miles. So now let me write this on the board so I don't lose this information. So I have what? 2,100 miles, 700 miles, 300 miles. 2,100, 700, 300. Now, I can do my triangulation. So let me clear all this. Clear annotations. Delete that. Clear that. Hold on. This. Take a picture of this.
What does this do?
Huh?
What does this do?
Later this week. I don't know. I said due date yet. I gotta see how long it takes to work through. Maybe I'll just make it Friday. See, I hesitate to say on Friday because then like 75% of the class literally won't touch it till Friday, and that's a little frustrating. Come on, I need to see 1 page. Here we go. Hold on. Cancel this. 1 page. let's view it in, yeah, there we go. Orientation, landscape. Oh, that didn't help. It just screwed everything up. There we go. And now, view one page. I can zoom in even further than that. 200. That work. Print screen. Okay, now we have our map. We're ready to go. Hold on. This, I do need, in my print screen, I do need the scale at the bottom. There we go. Now, print screen, and view. Okay, so when you do this, I think it's easiest, you can use a ruler. I think it's easiest to use a piece of paper. And I'll show you why. Because with the ruler, you have more numbers. And numbers make things more difficult. So what I have at the bottom is I have a scale. Because I've gotten miles from my chart. 2,100 miles, 700 miles, and 300 miles. But I can't measure those miles directly to the map. I have to use a scale to change that over. And so the scale is going to tell me how far those distances are on my actual map and allow me to write them down. So I'm going to start with my biggest one, 2,100 miles, and that was recorded in Los Angeles. And so I need to start there. How far is 2,100 miles? So I can measure this in inches. On my yardstick, 2,100 miles is like 22 3/4, which isn't too bad. But now I'm having to do measurements. If I just take a piece of paper, because y'all's is a lot smaller, if I just take a piece of paper and make a mark, like I'm just going to hold my finger here where this mark is, but you can make a mark with a piece of paper, and maybe go like from the corner and just make one mark. So you're always measuring from the corner to that mark. Now I know what 2,100 miles is on my piece of paper or my ruler, and I can go ahead and go in and make my little dots. So I'm going to put that corner right where Los Angeles is at, and I'm literally just going to make a whole bunch of little circle line dots and make a circle around Los Angeles. And so I'm going to put one here. I'm going to turn it, put one here, turn it, put one here. And I can probably go down now because I doubt it's going to be way up there off the map. And yeah, you can probably guess that your earthquake is going to be somewhere on the map and not off the map, which is really helpful. So this is not perfect, but I've got myself some marks here. And you can see that it's kind of like a semicircle. Yes?
Did you say 2,500 or?
It's 2,100
Okay.
miles.
That's what I thought. I just
Yeah.
thought you said 25. So.
No, it's okay. I might have, but yeah, it's 2,100. So once you get some marks made, and if you think they're a little further spaced out than they need to be, make a couple more in between. So you got a nice dotted line. Once you get those made, you can trace from line to line or dot to dot and get yourself this nice semicircle or arc going to draw your earthquake line. And so now, with just this one, I know my earthquake happened somewhere along this line. And I also know if I do everything right and draw my other two circles, all three circles should meet in one spot. And so that's what I'm looking for. So let me go ahead and do the other one. I got 700 from, what was 700 from? That was from Houston. So I'm going to come, and I might do this with a piece of paper now that I've got a smaller distance. Let's see what my distance is. Yeah, from that corner to 700 is right there. And so I'm going to do 700 from Houston. And again, the good news is I know that my earthquake has to be along that first line, so I don't have to do a full circle for Houston, I just need to do a little line through their line so I know where they meet. And, you know, even if I keep coming out here, I don't think that circle's going to meet on the map. So I know that while I could have kept going and it would come back around here, they would have met down here off the coast somewhere. That's probably not where my earthquake is for this example. So I draw my second line. And already I kind of know my earthquake's probably going to be right here in Alabama. No, that's Mississippi. Because Louisiana, then Alabama, then Mississippi, right? My geography people?
Yes.
It's a weird part of the world. All right. And now St. Louis, which should be even smaller. Only 300 miles for St. Louis. So let's just make a mark right there. Which didn't show up on my paper. Dummy. Yeah. And then you do your St. Louis one. St. Louis will be 300 miles. Make my 300-mile marks, and I could do the whole circle for this one. 10's a little bit off. Still not too bad. This is it's way off. Stupid pen. There we go. So that's not too bad. Mine was not perfect. So my epicenter is somewhere around here. Know that with the measurements I have, my 300, my 700, and my 2100, my circles didn't come together perfectly. They were close, but they didn't come together perfectly. I kind of have this triangle of uncertainty here. It could be anywhere from like the upper corner of Mississippi, Alabama, up into Tennessee. Yeah, that's Tennessee. Up into Tennessee, maybe even as far west as like the northeast corner of Arkansas. But somewhere in here around Tennessee, the northern area of Alabama and Mississippi, that's going to be where our earthquake was. Did everybody get something similar or close to it? Nice. And so this is by far not the biggest part of the lab, but it is one of the things they're going to ask you to do. And so know when we get back to the lab, here we go. When you get to, they're going to start you off on some generic things, and then, let's see. Yes, they have what? Well, I might have to fix a couple things. Looks like my images. Oh, because never mind. I turned it to the wrong layout. Everything's all messed up. Here we go. Let me go back. Yes. So when you get up here, where are we at? This is where you're going to do it in the actual lab. This little half globe kind of thing. You've got 3 different stations. Before you even get to this point, they have you measure the distances and the times. So you're going to get your 3 times. You're going to use the chart to get your 3 distances. And then you're going to come down here and actually triangulate with your 3 circles and figure out where your earthquake is. And so that's, again, not the hardest part of the lab, but it does require you to kind of know the steps and what to do. So this is the lab. I would go ahead and start working on it. I don't think it's extremely difficult, but it is a little long. How many questions we got? Like 40 questions. Which, again, you don't have to do all of them. There's some that are omitted. But, yeah, it's not the shortest assignment ever or anything. So go ahead and get going on it. If you have any questions, please let me know, especially when you get to the part where you got to draw the earthquake map. and I will post this online. I didn't post any of my videos from yesterday, so I need to catch up.